So at this point, we've learned about Alfred Wegener, who came up with the idea that these continents were once all connected to each other. But when Alfred Wegener told everybody, hey, I think this is what happened, everyone said there's nothing strong enough to actually move entire plates of land. It makes no sense. But now that we know more about molecules, we know that it's actually convection currents. And the thing is, this whole convection current idea can be explained with all the stuff we've learned about molecules in the past and how particles move as they're being heated up. Now we know that underneath the crust there's this mantle layer, and that mantle layer is made of molten rock. So this rock has melted and it's more liquidy. It can actually move around. The core of Earth, that geothermal energy right at the middle, is going to have some spots that are going to be warmer than others. And what ends up happening is it's heating some areas more, changing those molecules more, and other areas are just going to be a little bit colder. So here I have this convection tube. It's this rectangular tube of glass, and there's water in it. And the water is free to move all the way around. I've started heating up this bottom corner over here. And as I'm heating up this bottom corner, you can imagine that those molecules are getting all of this thermal energy. And we know that molecules start moving faster and they get farther apart, making them less dense, almost like the air in a hot air balloon, which starts moving upwards. Now, if this is correct, this water should be moving up, and it should be moving all the way around. Now, I'm going to add some food coloring so we can see if that's true or not. And as I add this food coloring, it's going to be moving in the direction that the water is moving. And we can see that it's spreading this direction and going down. This is happening underneath Earth's crust in that mantle layer. So while Alfred Wegener didn't know this was happening, now we know that there's just areas that are warmer, that magma or the mantle, like molten rock, is going to move up. And as it gets really high up away from the core, like over in this corner, it's going to cool down and it's going to want to move back down. Almost like a lava lamp. That stuff gets to the top, cools down, moves back down. And it just keeps moving like this. So here we can see that blue food coloring has moved this direction and it's going to keep going. Now, under Earth's surface, if this is happening and there's a plate on top, it's going to be pushed by the direction of the magma at the top. So if this magma is moving in this direction, because the heat is right here, this plate is going to be moving this direction. So it's going like this and it's pushing it over. So these plates can move because of this whole convection current thing. When there's two convection currents right next to each other, it depends on where the heat source is. So if the heat source is right in the middle for both of them, and they're both going up and over and up and over, the plates on top are going to be divergent. They're going to move this direction. If the heat source is on this side, on the outside, so I can move this over here, now I'm heating up this side of the water, it should start moving in this direction. And if I have two where the heat sources are on the outside and they're moving in this direction, we're going to create convergent boundaries. They're going to move towards each other. Now these can also be right next to each other, and this one's a little tricky to do with your hands, but one's going to be moving forward while the other one is moving backwards because the heat sources are on opposite sides and they're right next to each other. When that happens, we get a transform boundary. So they're going to slide past each other like this. So while Alfred Wegener couldn't explain this, now we know about convection currents, we know about molecule motion, and we know that this is the force that was actually strong enough. At this point, this side's been heating up. I'm going to add a little bit of red food coloring so we can just double check that that's right. I'm not even sure you guys can see that. I put too much blue. There we go. So the red is moving this direction and it's moving down. There we go. It's moving, it's going pretty fast. and it's going to go like this. So if there was a plate on top, this plate would be moving that direction. So remember, this creates convergent boundaries where the heat source is on the outside, that's where it goes up, and then it comes down. If the heat source is in the middle, it's going to go up and away, which makes divergent boundaries. And then, of course, we've got those tricky ones where they go like this. And I can never do this one.